Welcome back to calculus. We are going to do 8.3. I call these trig power integrals. This, honestly, when I took calculus, was one of the sections I struggled with most because I thought I could kind of just wing it, and it turned out that was difficult. So I'm going to kind of wing these in the beginning, but then we'll eventually, as we conclude things, we'll make some general observations that I think will help you have more success than I did. I also have a document I put together that I'll send you guys at some point that has a lot of the summary of some of the ideas and some of the techniques to make this not just seem like you're guessing and checking. So let's do a little review first with some basic integrals. So that is going to get us thinking about the kind of problems we're going to be doing. Remember how to integrate sine x, cosine x, dx. So we can't multiply these. We have to use substitution. It really doesn't matter what we let u be in one like this. Let's just let u be sine x. And then that would be du. So this just ends up being the integral of u du, 1/2 u squared plus c, or 1/2 sine squared x plus c. Right? If I had let, I didn't really think of doing this, but I guess I will. If I let u be cosine x, du would be negative sine x dx. So it would be the integral of, would that be, let's see, u times negative du, or negative 1/2 u squared plus c, or negative 1/2 cosine squared x plus c. Those are going to be the same answers because of the plus c there. You could use Pythagorean identities and show that they are the same. Okay, now I want to do that. So Pythagorean identity, we could do this, right? And that becomes 1/2 minus 1/2 cosine squared plus c, x plus c. And then this 1/2 plus c is just some other constant, right? And so it's the same thing as negative 1/2 cosine squared c cosine squared plus some constant. So we don't know what the constant is, so they are the same. So either method would work. I wasn't really intending to make that difficult, but just don't be stressed like one technique works and the other one won't work. Let's do one more review and before we do something kind of new. What if you had sine x cosine to, say, the 5th x dx? This one you have to choose it a certain way. Who's your u? I guess here are options. Is u sine x? Is u cosine x? Or is u cosine to the 5th x? You might recall me saying we'll never let u be cosine to a power, or a trig function to a power. So that's out. U is not going to be cosine to the 5th. U is either cosine x or u is sine x. Let's just explore. If u were sine x, du would be cosine x, and you'd have 4 extra cosines laying around. Doesn't work. If u were cosine x and du were negative sine x, hey, that's going to actually work. This becomes integral of, so remember that's cosine x to the 5th, so we have u to the 5th times negative dx, du, sorry. In other words, negative 1/6 u to the 6 plus c, or negative 1/6 cosine to the 6th x plus c. Okay, so we can do those, and I guess the lesson learned there is let your u be the thing that's to the power. Don't put the power on it, because you can just easily just have a 5th there, and it's easy to integrate u to the 5th. So if you have 1 to a power and 1 not to a power, let u be the one that's to the power, but don't put the power there, okay? So just like this, u is cosine x. If it was this, u would be sine x. and everything would work out really nice. Okay? So those we've really kind of already known how to do. But now we're going to jump into the new thing. So these were both review examples. And I'm going to do, I hope, two or three more before we end this video. And then we'll probably have a part 2 as well. Maybe, hopefully, we'll do it in 2 parts. So this is truly my first example for 8.3. And I'm going to do one tiny change that's going to cause some problems. Now I have both of them with powers. And really, the only difference is I made sine, just bumped it up 1 degree. But what are we going to do? So let's run through maybe our options that we're thinking right now. What if u is sine x? Well, then du would be cosine x. But again, I'd have 4 extra cosines. No good. What if u were cosine x? Then du would be negative sine x, and I'd have 1 extra sine. No good. So we have to do something. Actually, in the end, u is going to be sine x, but we have to do something first. What I want to do, and one thing you might have noted that was so nice on these others, is my du was always a single, right? There was only let's switch my color up here. There was a single sine x, and that was very nice to become my du, right? There was well, both of them were single here, so either one could be my du nicely. I don't have a single one on this one. I have both of them with powers. So what if I could make one a single one? That's what we're going to do. And which one should I make a single? Should I do sine x, cosine fifth? You'll see why, but I'm going to actually make the single one my cosine x. So that's the same thing, right? I just pluck a cosine x out of cosine of the fifth, and now it's that desired single. But the problem now is this term. You're like, oh, this guy, if he was just gone. Or what if I could write that where it's all sines instead? And you can't, right? Can't you do this? So this is what this is. These are going to be a little bit long at times. Couldn't you write this as that? And this is kind of one of those extra steps you're not going to have to do. But the reason I'm doing that is because we know all about cosine squared, right? We know that it's equal to 1 minus sine squared x. So what I've done, I plucked out a cosine, and you might wonder why I didn't pick sine. We'll come back to that in a second. Well, here's why. Because I plucked out a cosine because the remaining portion is now even right here. It's even. And since it's even, I can write it as a multiple of squared functions, or a power of squared functions. And the squared functions, I can use the trig identity to change to the other, to his Pythagorean buddy. In this case, change cosine squared to sine squared. So you want to isolate in the beginning the odd powered one. If you're an odd power, you can pluck one out, plucked out. The remaining are even. Those can be written as a power of squared ones. You can use the Pythagorean identity, multiply it out, and go from there. I hadn't really thought of this, but I think I'm going to try it. I'm going to go off my notes here. I think I can do U substitution right now. No? Well, okay. Yeah, let's do it right now. You could, or you could go ahead and multiply this out, but we need to multiply this out eventually, because otherwise it's a product, and we can't have a product. But we can tell already that our u is going to be sine x, and our du is going to be cosine x dx, because there they are, kind of plucked off, ready to go. All these sine x's are going to be replaced with u, so this now becomes integral of u squared times 1 minus u squared du. How you like that? So the reason I think substituting early was nice is because it's easier to deal with this rather than all these squares. When you square this, you get 1 minus. You can check me on this. I'm not going to do this in front of you. And then we want to multiply that through, and we get u squared minus 2u to the 4th plus u to the 6th. And you can take a sigh of relief. This is a very doable integral. 1/3 u cubed minus 2/5 u to the 5 plus 1/7 u to the 7 plus c. plug back in, and this one is finished. 1/3 sine cubed x minus 2/5 sine to the 5th x plus 1/7 sine to the 7th x plus c. Got it. So again, our lesson was we found the odd one, plucked one out so that it was even, changed all of those to its Pythagorean buddy. So that one, let's do one more. It's a little bit simpler, and hopefully this will make a little more sense to you here. This is example 2. The integral of sine cubed x cosine squared x dx. So who should I pluck this time? You want to pluck out, oh, let's not do that. You want to pluck out a sine x this time. Because, I got a little message there. You want to pluck out a sine x this time. Because sine originally was odd, right? So we pluck out a sine, and the remaining portion's even. I can change that to 1 minus cosine squared x. And I think we're good to go. Very similar to the last one, except I'm not going to have to do that squaring. So my u is a thing where kind of have a multiplicity of stuff. So I have lots of the cosines. My du is my single one that was plucked out. We do have to deal with this negative here. Oops. Okay, so this can be substituted as 1 minus u squared times u squared d negative du, not minus, but times a negative. Bring the negative out front, and this is u squared minus u to the 4th. Actually, might as well switch the order of those two. U to the 4th minus u squared. And we take this integral and we get 1/5 u to the 5th minus 1/3 u cubed plus c. Plug back in. And what was u again? U is cosine, so 1/5 cosine to the 5th x minus 1/3 cosine cubed x plus c. And that is that. I think I'm going to stop this one here. We'll just do 3 little videos. Hopefully that makes sense. It's kind of an introduction to this idea, looking for a odd powered, plucking out a single one, take the remaining ones, switch it to the other. And I'm going to write, like I say, I have a document to send you with all that written up. But hopefully this is making